All right, we're going to try to explain scope and variables here. Let me get some of this stuff commented out. All right, so we're going to start up here with these guys. And I'm going to start off by showing that variables by themselves are defaulted to being immutable, which means, so if you hear something that says a variable is mutable, it means that you can change it. And if you see something that says that it is mutable, you can change it. Immutable is you can't change it. So what you're in Rust, everything is immutable, which means you can't change it by default. So if I do this and I say let I, which is an I32, an int32, set it equal to 5, and I32 means that it's a signed integer. It can be negative or positive. If I do a U32, then it would be an unsigned. So if I take this variable and I try to assign another number to it, let's just see what happens here. So we're going to run this. And you'll notice that it says that let's see, where did it do it here? Cargo run, find function. All right, hold on. I got to comment out the other. Let's comment out this guy for a second. So we're defining I, and we're going to try to set the variable to it. So you'll notice right here we've got I, and it says first assignment to I, make the binding mutable. So it's telling you how to fix the problem, but it won't let you set it. It says cannot assign twice to a mutable variable. So it's telling you right away that is not, you can't change it. All right, so I'm going to comment out this problem, and we're going to throw this function in. So now what we're doing is we're going to call function 1, and we're going to tell it that, so look at what's supposed to happen here. So we define a variable, we set it equal to 5, we call function and pass that variable in, and then when it comes back from the function, we're going to print what I is. And then down here, we're calling this variable 1. We're going to change its variable to 22, print it, then it's going to go back up to the main and print the original variable. So let's see what happens here. So again, what you see here is the system can't change the variable, because when we brought in this variable down here, we brought it in as a regular variable, I32, which means that you can't modify a variable. It's immutable. So in order for us to fix this, we have to actually change the variable to a mutable value. Now, to do that, let's comment this guy out. So we're going to do here, get rid of that, come up here, Control V, boom, boom. All right, so we're going to come down here and grab all this and activate it. So this is going to be function 2. Okay, so look at what this does. So it's the same variable that we had up here, but this time we put mut in front of the variable name. So we're saying let mutable I, same type, equal 5. Then we're setting I equal to 7. And this time it's going to let us set I equal to 7 because it's a mutable variable now. Now it works just like every other programming language. So this literally is backwards from every other programming language that you've probably ever used. Then we're printing the new value of I, which should print 7. But look at how we're having to pass this into function 2. So by default, if we only pass I in, it's not going to let us change the value of I in the function, because when it goes into the function, it's going to end up being immutable again inside the function. So we have to pass it in as a mutable object. And then you'll also notice that we're passing this ampersand in the front of mute, and that is because we need the address of I passed in, because we want to make sure that if we make a change, that we're changing the original variable and not just changing I. So as an example, if I were to pass this in like this, when we come down here, the variable would come in. Let's get rid of mutable here for just a second and see what happens. See, we get back down here or let's see, I32 cannot be dereferenced. Oh, hang on one second. I got to get rid of this guy. Oops. I hit something that pulls that thing up all the time. So let's go here and let's do cargo run. So I32. So again, you see it comes in and tries to change the variable to 22, and it again says that it's immutable because it can't change it if the thing comes in as immutable. So even though we can change it up here and we have told it that I is equal to 7, when we call function, we passed it in as a regular variable. And so when it comes into the function down here, it again is immutable. So we need to pass this guy in as mutable, and we're also going to pass in the address of this variable. So we're passing it by reference. And then down here, when we declare this variable, we're going to declare this as ampersand mute variable 1. So now, if we go out here and run this, we have, let's see, I got something wrong. Mutable, found mutable 32. Oh, when you do the function, you don't put the mute here. The variable stays there, and we actually put the mute over here by the type. All right, and so now if you look at this, it says expected a mutable I32, but it found an integer. Well, if we look, and right here it tells you consider dereferencing. The reason is because this is something that Rust considers a borrowed piece of memory. And so in order to get access to this piece of memory, we have to dereference this variable. And we do that with an asterisk symbol. So we're passing in the address of this variable. We're modifying the contents of the thing. So if we didn't put this, it thinks we're trying to modify the address of the variable instead of the content. So we have to dereference. This works pretty much the way C and C++ work for passing pointers in and then dereferencing those pointers so that you can actually change the value, because otherwise you're changing the address. So let's do this again. And so now you can see that we passed in 7, and then it changes it to 22, and then when it comes back to main, it's 22 again, which means that we modified the original variable. So we didn't make a copy of this variable. Now, Rust uses the stack to handle integers and floating points and those kind of things. And so when you pass a variable and a number, an integer or something into a function, it makes a copy of it and works with that copy. And that's why when we had this thing defined as not being mutable up here and we tried to call it down here, we couldn't modify it because it didn't pass the original mutable variable. It actually made a copy of it and tried to use it. So now we're passing in the address, the actual reference to that variable. And so by that same token, we've got to dereference it so that we can work with it. Now, that's pretty much the way that you would expect something to work when you're working with integers, and other than the fact that it's opposite the way that most things work. In other words, it's dereferenced, or I mean it's mutable or immutable instead of mutable by default. Well, let's take a look at what happens when we do this. So what's going on now is we are defining a variable called s, and we're telling it that s is equal to hello. Then we're calling function 3, and then we are going to print what s is when it comes back over to the function. Now, this is where things get a little bit funky. Because strings are not part of the stack, they're actually defined in the heap, and the stack is only holding an address to the heap. So the stack itself is where the address and a few other bytes of information are stored, and then the heap is where the variable is actually at, or where the contents of the variable are. And because of that, when we reference this string up here and we pass it in, Rust doesn't have it doesn't have a garbage collector. And so in order for it to clean the memory up, it looks at who owns the memory and who is currently in scope. And so what happens when we set a string or a referenced object that's actually in the heap, what happens is that when we call a function or we set something equal to that particular value, Rust will actually change the owner of that value to the new owner, and whoever owned it originally goes out of scope. So they immediately lose scope, and now the new owner has the scope, and when they let go of it, the variable's gone. So you can't have two variables pointing at the same place in memory, and it does that to get rid of the potential of fighting over the same memory area and having things work in a way that you don't really expect them to work. So what is going to happen now is when we run this, it's going to define the string, it's going to call the function, it's going to come down here in the function and print the value of whatever the string is. But when it comes back up here and tries to do this second print line, it's not going to have a reference to s anymore, because s, the ownership of s, was given to the function, and the variable s that we actually had up here in this function, or in the main function, is gone. So let's check and see if that's what actually happens. So move occurs because, so right here it's telling you that a move occurred because it doesn't have a copy trait. So the string itself can't be copied. And so when we made this function s, it moved here. So it's telling you that the original s that you had up here is moved, and therefore the value was borrowed after the move. So you can't run this function because, and just to show you, if we go back in here and comment out this guy, it runs fine. So we can't have two things pointing to a string or any other type that is actually going to get stored on the heap. So anything that's stored on the heap and not in the main part of the stack is going to end up getting referenced like this. So when you call and pass that object into a function or into anything else, you're going to end up losing scope. Now you can return that item back to the original item or original function, but there's a better way to do that, and that gets back into using these mutable items again. So we're going to come down here and we're going to comment out this stuff. And also you'll notice here I've got this s.pushString world. If I meant to uncomment that, just show that this variable is immutable. You still can't make a change to it because it wasn't defined with a copy state. So the variable would still not work. Let me do this. All right, so this time what we're doing to take a look at this is we're telling this that s is actually going to be a mutable object, which means we can make a change to it. It's going to be a string, and then we're going ahead and setting it to from hello. We're going to call the function that we're working with, and we're going to pass in the address of the mutable s. So just like we did with the integer, we're doing the same thing here. And this time when we come back to main, we're going to print out what S is. And then down here in the function itself, we're using the s.pushString to add. We're basically appending the world onto the end of hello. So we should end up with hello world. And then we're going to print out what S is down here. And then when we come back, we're going to print out S up there. So we're going to save this. We're going to go out here. So you can see that it says hello world, and then back in main it says hello world again. So essentially what happened there is we modified the original string that we were pointing to in the main function. So the strings get a little bit wonky because of the fact that their reference is in the stack, their value is inside of the heap, and if you hand that off to a function, you're going to lose it. So anytime you hand a string off to a function to use it, let's say you have let's say that we go back to our original program that we were working on, and we modify it so that we have a function that's actually going to open up the files. Well, we have to pass the paths in. So we grab the path, we pass it in and tell it to open the file up. We're going to pass the file handle back to the original program. But when we pass that path in for the end file, we're going to lose that path, because as soon as we hand that variable off to the function, we lose scope inside of the main function, and we no longer have the path. So that's an example of why you have to kind of be wary of what is going on. Now, I want to mention one more thing here. If I were to come in here and say, put some braces around this, and I were to define a variable inside of here and say let I equal 32, this variable only has scope inside of these braces. So the braces dictate scope. So if I have braces and I define a variable inside of those braces, then it only has scope inside of those braces. And you can put braces anywhere you want, even if you don't have an if or a while or for or whatever it is that you're doing. So if you want to do a little block of code and make sure that everything's cleaned up as soon as that particular function gets done, or that piece of code, throw some brackets around it or braces around it, and it'll automatically get rid of all the memory when it leaves. So scope is a big deal with Rust. Ownership is a big deal. And then there's a few other concepts that I'm still getting my head wrapped around that I'll cover in some future videos. But I wanted to mention this because one of the things that I want to do in our program that we're working on is to throw some functions in there to do some of the stuff so that our main function isn't quite so convoluted with a bunch of different code. So this kind of hopefully explains a little bit about how these variables are handled. It's still a little bit, you got to think about where to put the mutable syntax. You know, here it's in front of the variable here, but when you're actually doing the function, it's in front of the type instead of the variable. Little things like that are going to take a little bit of getting used to, but overall it's pretty straightforward. There's not a whole lot of craziness here, other than the fact that our variables are not mutable by default.